nitrogen, phosphorus, arsenic, antimony, and bismuth. Okay. So in that nitrogen oxy acids, phosphorus oxy acids are very important. And from Oswald process, there is a nitric acid preparation is a 10 marks question. And also I told that 5 marks bits are very important bits, are compulsory bits, are preparation of superphosphate, preparation of hydrazine and hydrozoic acid. 5 mark bits. Oxy acids of nitrogen also 5 marks bits. Phosphorus oxy acids must have 10 marks question. And Oswald's process by means of the nitric acid preparation is a 10 marks question from the 5th A group elements. Please, that is nothing but everybody is saying what important questions are important. These are the important questions only. So if you are attending the class means we'll get the important question. Which is the important only I am here explaining for your purpose. Why? Because the vast syllabus, I can't complete all each and every word. Only the important topics I am elaborating and we are discussing with you for your understanding purpose. Okay. After that, we are already, I told that yesterday, that is last class. Next, today's we are going to start in the black 2, that is the organic part, black 3 also organic part. Okay, now we are going to the organic chemistry. So in that organic chemistry, that is particularly black 2, consisting of, you are having of the 3 units are there. The first unit is, in this first unit is alkynes. So the continuation of your first sem consisting of the, what is the basic concept of the organic chemistry, the first chapter. Second chapter is alkanes and third chapter is alkenes. You have learned that one. Now here in the continuation of in this particularly is that you are having of the open chain compound, cyclic compound. In the open chain compound, the classification of the third classification is alkynes. It is unsaturated hydrocarbon. Alkynes are unsaturated hydrocarbon. The carbon-carbon, the bond, there is a triple bond is present in this one. So there is a triple bond is present in this series. This is called as a unsaturated hydrocarbon. Alkynes are unsaturated hydrocarbon. The functional group is in this unsaturated hydrocarbon is triple bond. This triple bond, in this triple bond, particularly this one, we are elaborating that how getting of the remaining members of the alkyne series means the general formula of alkynes. General formula of alkynes is CnH2n minus 2. Now the minimum number n is equal to 2 only. Why? Because there is a double bond between a triple bond between the 2 carbon atoms. So n must be 2 only, not 1. So if n is equal to means it is a compound is C2 and H2. Okay, this is called as the IUPAC name is 2 number carbon is ethine. Ethine is the IUPAC name. Ethine is IUPAC name, but the common name is it is called as ethylene. Please remember here you are having of in the alkene series, the first member is ethene. Ethene is the IUPAC name, but the common name ethylene. Ethylene you are saying here. Ethine is the IUPAC name. Ethylene is the common name. So this is the first member in the alkyne series. When you go to the 3 C3, so it is nothing but C3 acid means C3H4. This is a propine. It is a propine. Whether it is a 1 propine or 2 propine, depending on the whatever the functional group is, it is a only 1 propine. Why? Because the carbon atoms are only 3 carbon atoms are there. Suppose we are writing of this triple bond in this particular first carbon. Here same number 1, 2, 3. Suppose if we are writing here only, this is 1, 2, 3. That means the triple bond is present. 1 propine it is called as. But depending on the higher, more number of carbon atoms are there, the particular triple bond will be changes to one place to the other place. That means only the particularly the alkyne series position isomerism. Position only changes for higher members. This position 1 may be changes to the 2, 3 like that. That's why alkynes are exhibit only positional isomerism, not cis-trans isomerism. Please remember why the alkynes are does not exhibit cis-trans isomerism. If you required of cis-trans isomerism means there is a requiring of only double bond is required. That means only alkenes. In the hydrocarbons, only alkenes can exhibit cis-trans isomerism because double bond is present between the carbon and carbon. Double bond means alkenes. So alkyne, there is no chance of getting of the cis trans type. Only the chance is the position isomerism. Position of the functional group will be changes. Okay, friends. So this is about the main important of the alkynes. Now coming to the general information. This means triple bond is general, formula is, and the examples of the alkynes. In this particular triple bond, it undergoing of sp hybridization. What hybridization is present means in the alkyne series is sp hybridization is present. So sp means what is the bond angle of sp? This is nothing but the bond angle of this acetylene molecule is having of 180 degrees. Now see this particular structure. I am writing the same formula of CnH2n2 only. This is ethine. See, this is a linear structure. That means linear structure is there. 180 degrees. This is a 180 degrees is present. Okay. 180 degrees and linear structure sp hybridization is present. The bond length between the triple bond. If you are seeing the single bond length, the carbon-carbon single bond length, that means alkanes is 1.54 angstroms. 1.54 angstrom. Carbon-carbon double bond length 1.34 angstroms. And carbon-carbon triple bond length, the bond length is 1.20 angstroms. Please remember 1.54 is a single bond, 1.34 is the double bond. This is a single bond. Okay. This is a double bond, and a triple bond means it is triple bond. So the bond length is the 1.54, 1.34, 1.20 is the triple bond length. Thus alkynes. See, in this multiple choice question is general formula. What is the hybridization? What is the bond angle? What is the structure? What is the bond length of the triple bond? 4-5 questions are here only. Multiple choice question. In any paper, definitely one of question from the out of 5, you will get one question. So that much of introduction is important of this particular alkynes. So you have to remember this is the alkynes. It is a very that means very unsaturated triple bond is present in this, so that it can undergoing a oxidation reaction mostly. That means saturated compounds are undergoing substitution reactions, and unsaturated compounds are undergoing of addition reaction, removing of the bond. That is a double bond or triple bond. Here it is happened. This is about the interaction part. So friends, here remember multiple choice question. 5 questions are there in this particularly. Now we'll go to the preparation of generally. We are discussing about the alkynes preparation. So preparation is 10 marks question. Preparation of alkynes. How to prepare? The first is the industrial method is there. Already I told in the last class, carbides, calcium carbide, methyl carbide, aluminum carbide. When the aluminum carbide has hydrolysis, you will get the methane gas. Here calcium carbide is hydrolysis. You will get the acetylene gas. Already told that. Acetylene gas is the calcium carbide is used for the purpose of what? Already I told that artificial ripening of fruits and vegetables. Now today you are getting off the seasonal fruit. There is a mangoes are getting off. In the vendors we are getting off the what is the vehicles. So yellowish color. It is not a complete one. It is not ripened artificial. It is only artificial, not natural ripening. Natural ripening is a partially green and yellow color, but you are getting of artificial ripening. Complete yellowishness is there due to of the calcium carbide is used by that particular fellows vendors. Okay, this the calcium carbide is a very dangerous one. Our India, the government is banned the calcium carbide, but even though from China they are supplying the calcium carbide. Okay, for the artificial purpose we are using. So preparation of alkynes, this is particularly acetylene gas. That is industrial method. This calcium carbide is hydrolyzed. Simply you are getting off C2H2. That means acetylene. That is nothing but you are having of the structure is triple bond CH. This is nothing but you are having of, and what happened? Calcium hydroxide will be liberated. Calcium hydroxide what? Lime water. Okay, lime water is, that is a, you are getting of calcium hydroxide, the lime water will be there, the byproduct is there. So spraying of like that calcium carbide on the fruits, we are getting of this one. This is an industrial method preparation. And the second method of preparation is when you are using of the second method, dehydrohalogenation. The second method is dehydrohalogenation. See friends, here if I seeing of this particularly dehydrohalogen means what? You are removing one hydrogen, you are removing of halogens. Dehydrohalogenations. In this case, dehydrohalogenation, we are using of the compounds are, I am writing the compound. Can you say the name of this IUPAC name? Anybody? Dihaloalkanes. The halogen, either chlorine or bromine, whatever. Dihaloalkanes. This is called as dihaloalkane. When dihaloalkanes, you're removing of particularly hydrogen and that halide group in the presence of alcoholic potassium hydroxide. Please remember this reagent. This reagent, what do? They do the removing of halogens and also hydrogens. The first you are getting of the one hydrogen and one halogen is removed by this place. Okay, so you are removing of this halogens and removing of this halogen first. So getting of a double bond means CH, X, a double bond is present, and here you are getting of HH. Again, in presence of, that means reagent, it is present in the reaction. Again, removing of this one, you are removing of this one. So you are getting of acetylene. That is the alkyne. Alkyne is also called as acetylene. It is a general name. Okay, it is an alkyne. Or you can say called as ethyne. Don't say alkyne, ethyne. Ethyne. Ethane is called as acetylene, the common name. Okay. So this is a one more method, dehydrohalogenation. Dehydrohalogenation in presence of what? Dihaloalkanes. When dihaloalkanes are reacted with the alcoholic potassium hydroxide, you are replacing the one by one hydrogen, and means it is a one HCl is removed or one X is removed, HX. Again, same one HX is removed, whether it is a chlorine or bromine, whatever it is, depending on the X group. What you are using? Suppose you are using of the chlorine means 1,2-dichloroethane. Example, shall I write the example on this case? If you see, if you want the interest of that one, the example means CH chloro means the name is 1,2. This is the first position, second position. 1,2-dichloro. What is the number of carbons? 2 means ethane. 1,2-dichloroethane in presence of alcoholic potassium hydroxide. I am removing a excess amount of alcoholic potassium hydroxide. Removing of 2 at a time means 2 HCl is removed. So you are getting of CH triple bond CH means acetylene. Excess amount of alcoholic potassium hydroxide is taken, immediately removed by the 2 molecules of HCl, you are getting of acetylene. This is an example of dehydrohalogenation. This is the second preparation of dehydrohalogenation. Next preparation, if you see that one, why? Because in the examination 10 marks question, at least you have to write the 3 preparations. There is the important of that one. And the next is dehalogenation. Dehydrohalogenation. Third is the dehalogenation. Dehalogenation means only halogen is removed. That is called as a dehalogenation. Dehalogenation means here tetrabromoethylene. Tetrabromoethylene. It means 4. 2. So tetraboro. You are getting of bromine. These are tetrabromo. Requiring of one more bond, which is replaceable. This is the means 1 1, 2 2. Position is 1 1 2 2. To 1 1 2 2 tetra means 4. What is the halogen is there? Bromo. It is a bromo. What is the name? It is the ethane means ethylene. Tetrabromoethylene or ethane, whatever you want. Okay, tetrabromoethane or ethylene tetrabromide. You are getting of. Don't confuse here. Ethane Better try ethane. In presence of zinc dust, previously you are removing of this one particularly. So dehalogenation, tetra 1122 tetrabromoethane in presence of the zinc dust. So you are using of the zinc dust, 2 units of the zinc dust. Immediately all the 4 molecules, that is the tetrabromoethylene, is removed by the, we are getting of the ethylene molecule. 2ZnBr. Okay, so 2ZnBr2, zinc bromide, ZnBr2. Okay, you are getting of 4 molecules will be replaced one. This is called as a dehalogenation. See how simple of the preparations. First simple is industrial method, calcium carbide hydrolysis. Second method is when 1,2-dibromoethane on alcoholic potassium hydroxide, dehydrohalogenation takes place. Dehydrohalogenation means removing of one hydrogen, one halide group. Dehalogenation means all halogens are removed. Halogens are removed, that is called as dehalogenation. That is tetrabromoethane or ethylene tetrabromide is reacted with the zinc dust. We are getting of ethylene molecule, ethyl molecule and zinc bromide. These are the 3 preparations, very important preparations. Your examination point of view, you can use it. Okay, next they ask, write the preparation and properties of the alkynes or ethylene molecule. So if these are the 3 preparation, you will get the 5 marks. Next, you are thinking about the properties. Now the properties of, why? Because it is a very simple one. Just you have to practice it. It is a mathematical expressions, means no marks should be cut. When you are attempted this question, means you will get the out of 10 marks, the 10 marks they will give. Why? Because all are equations, no writing part. If you are writing part means, suppose calcium carbide, what is the industrial method? When calcium carbide, words in words, when calcium carbide on hydrolysis, you will getting of ethylene molecule. That's all. Dehydrohalogen means when the that is dibromoethane. When dibromoethane is treated with the alcoholic potassium hydroxide, formation of ethylene molecule. Or dehalogenation means when tetrabromoethane is reacted with the zinc dust, formation of ethylene molecule. These are the words you have to write, that's all. But the equation is very important. Now coming to the properties. In these properties, the physical property, it is a colorless gas. Ethylene is a colorless gas, but it is in garlic smell. It's a garlic smell. When you are using household purpose for the food purpose, that is a garlic is there. It is a very garlic smell, highly, and also you are getting of this particularly unstable one. This particular ethylene molecule is a unstable. Coming to the chemical properties, the chemical properties, the first is the you are having of the reduction. Reduction means hydrogenation. Hydrogenation means what? We are getting of the first preparation. There is a properties. If you use this particular hydrogenation, this is the first sem we are having of the first sem. What is a hydrogenation means? When alkynes, hydrogenation, adding of hydrogen, this is called as a reduction also. Adding of hydrogen is called as a reduction, adding of oxygen is called as oxidation. Okay, hydrogenation is nothing but when the formula, general formula is CnH2n-2. When adding of hydrogen in presence of nickel or platinum, the catalyst, what happened? You are getting out CnH2n. This is nothing but alkene. This is alkyne. Very simple property. This is used for the your preparation of alkenes. Or if you are further hydrogenation, you are getting of alkanes. That is in the first chapter. That is the same one. In that hydrochemistry, that means organic chemistry, first chapter you can prepare, alkanes prepare. You can also second chapter, alkenes prepare. Now I want to only the chemical property. That's why I'm using of when the alkynes are hydrogenated, means adding of hydrogen in presence of nickel lattice, you are getting of alkane. You can further means you can write it. That is alkanes are from. That is enough for this particular purpose. So this is about the hydrogenation. Next is second is halogenation. See, hydrogenation means adding of hydrogen. Halogenation means adding of bromine. Next, I'm using of simple, that is a ethylene molecule. Okay, so the bond is there. When ethylene molecule adding of halogen, halogen is a bromine. In presence of the catalyst is important here. Iron chloride, ferrous chloride. Ferrous chloride is important here. Nickel platinum or nickel or platinum, whatever you want. Nickel catalyst is used here. Ferrous, in presence of ferrous chloride only the halogenation takes place. The halogen, how the halogenation will be takes place means first the bromine molecule will be adding of this one. removing of the one bond. Okay. Next, again, further halogenation takes place. See the first halogenation. Now I am taking off this one. Just bromine. One bond is broken out. Only a second bond. Okay. One bromine. We are getting off hydrogen. Further halogenation means adding of bromine. And in presence of ferric chloride. So again, one more bond will be broken out. We are getting off bromine. Bromine H. See, this is tetrabromoethane. Just now your preparation purpose used one. Tetrabromoethane. Tetrabromoethane is again you are preparing here for the properties purpose. There from the this particular tetrabromoethane, you are prepared the ethylene gas. Okay. Why? Because you are preparing the ethylene gas within the presence of zinc dust. Zinc dust, from that zinc dust, just particularly halogens groups are removed out, you are getting off. But here in presence of ferric chloride, again you are getting off the tetrabromoethane. This is a addition of, that is a halogenation. And the third is the hydrohalogenation. This hydrogen halide, we are adding up the, this is all our properties are addition reactions only. We are adding up that one. Hydrogen is added, halogens are added, and hydrogen halide. HX, addition of hydrogen halide is adding off that one. When ethylene molecule, triple bond, hydrogen halide means HBr is used. This is a hydrogen halide is added. Simple case. What happened? One hydrogen will be present, another bromine will be present. So the reaction will be without reagent only. This can be formed as like this. See the mechanism. Means 1-bromoethene. 1-bromoethene is first form. 1-bromoethene is the first reaction we are getting off. Okay. Second step, again the halogenation means we are getting off this particular hydrogen bromide, HBr, if we are added. Next, what happened? In the second place, there is a bromine group and the bond is broken out. Already bromine group is there. We are getting off hydrogen. See, this is 1,2-dibromoethane. 1,2-dibromoethane is again preparation purpose we have taken as 1,2-dibromoethane, dehydrohalogenation. Okay, hydrohalogenation. When 1,2, that is a 1,2-dibromoethane in presence of alcoholic potassium hydroxide. In presence of alcoholic potassium, you are getting off this one. Here in presence of this one, same reverse order we are using of these properties. This is a common property, halogenation, hydrogen halide. This addition of hydrogen halide is there. Okay, this is the third property. See, very important, very simple equations only I am using up. If you are going to the your manual book, if you see that, you can't understand. Why? Because Vesnal halogen, geminal halogen. What is a Vesnal hydrogen? What is a geminal? That is a confusing is given by the reactions are there in your book. That's why I have given a short route. These are very simple equations. Halogenation means we are using of this one in presence of ferric chloride. Hydrogen halide means the simple hydrogen halide is added. This is the initial step. Again, it is further reaction will take in of the last compound. You can't further hydrogen halide. Why? Because already the bonds are removed. Single bond is there. It is a stable molecule. You can't take the addition reaction. Why? Because this saturated hydrocarbon does not undergoing addition reaction, only substitution reaction. Further addition reaction does not form. So these are the three are very important. Apart from the three, one more is very, very specially they are asking of the property that is called as hydration. What is addition of hydration? Hydration means adding of water. The fourth property means hydration. What is hydration means? Here particularly this is in presence of is very, very important here. So whether it is a ferric chloride or whatever what we want, here in presence of you are using of in presence of concentrated sulfuric acid, in presence of concentrated sulfuric acid containing mercuric sulfate. Containing mercuric sulfate is there. These are the two are very important. See the mechanism reactions. When you are using of ethylene gas, it is hydrolyzed, but in presence of sulfuric acid and containing of mercury sulfate, simply form acetaldehyde. This is acetaldehyde. Yes, how to prepare acetaldehyde from ethylene? How to prepare acetaldehyde from ethylene means ethylene in hydrolysis in presence of concentrated sulfuric acid. You can write the concentrated sulfuric acid containing mercury sulfate. You are getting acetaldehyde. But intermediate product is there. Vinyl halide is vinyl. That is a you are getting of the one bro. That is you are getting of vinyl alcohol. Vinyl alcohol you can call in intermediate product. Vinyl alcohol further you are getting of the hydrolysis. You are getting acetaldehyde. This acetaldehyde further oxidation you are getting of acetic acid. See, sometimes it is also asked how to prepare acetic acid from ethylene gas. This is acetic acid. Only further oxidation takes place. This is called as oxidation. Okay. So this is a very, very important property. It is a chance of getting up the 5 marks bit separate also, not in the long question. How to prepare acetic acid from ethylene? How to prepare acetaldehyde from ethylene? That means ethylene gas, that is ethylene is hydrolyzed in presence of concentrated sulfuric acid containing mercuric sulfate, formation of acetaldehyde. Acetaldehyde, further oxidation, you are getting of acetic acid. This is a very, very important one. And the fifth one, suppose this is also they ask how to prepare oxalic acid from ethylene gas. Oxalic acid. So ethylene gas oxide, that is called as a oxidation. When the ethylene gas is oxidized, ethylene gas is oxidized in presence of what is a good oxidizing reagent? Potassium permanganate is a good oxidizing reagent. So ethylene gas is we are using of oxidation means it is an nascent oxygen. We are getting of in presence of potassium permanganate. We are getting of this is oxalic acid. So in this one, acid group, this is the acid group. COOH is formed. This is the oxalic acid. Okay. This is the formula is H2C2O4 oxalic acid. Indirectly in the multiple choice question, what is the formula of oxalic acid they ask? So H2C2O4 is called as oxalic acid. This is a structural formula. When this oxalic acid further oxidized, you can further suppose oxidation theory means only carbon dioxide water is liberated. This is a form of that one you are getting up, but mostly up to this is enough. Why? Because they in the examination point of view, how to prepare oxalic acid from ethylene, how to prepare acetaldehyde from ethylene, how to prepare acetic acid from ethylene. These are the important one we are using of. This is the properties. So the 5 properties from the out of the whatever the properties we are having of that one.
Sir, what is the formula of potassium permanganate? Once again, repeat.
Sorry, potassium permanganate act as a catalyst only. Yeah.
Sir, what is the formula K?
Potassium KMNO4. KMN, manganese, potassium, oxygen, 4 molecules.
Okay.
Right? KMN, manganese, Mn, capital L, small n, O4, potassium permanganate. Okay. Somebody disturbed my... Who is Paval Kalyan? Mute yours, that one. Okay. Are you visible now? Full screen. My getting off only 1/4 screen is coming over. This one. So Pavan Kalyan is came or just now is added. Okay. So this is about the properties. Then after the uses. Uses are also asking for the 5 marks bit. What are the uses of the ethylene or ethane? Ethylene is main important ethylene gas used for the welding purpose. If you see that in the road, if you are arc welding, it is called as arc welding. Not arc means gas welding. You are having the 2 types of welding purposes there. When their rod is there, they are welding, and one is a gas. A cylinder will be there. There is a lime is there. They are used as that is a gas welding. So all the metals, this gas welding is a very, very important research. It is a strong one. So cutting and welding purpose, the ethylene gas is used. There's one use. And the second use, already I told that it is artificial ripening purpose ethylene gas is used. The fruits and vegetable artificially ripen purpose, the ethylene gas is used. Not only that one, for the using of the dyes. Dyes means colors, paints. In that paints, perfumes, and also plastic industry and rubber industry. Perfumes, plastic, rubber industry mainly, and dyes, colors. They are using in the ethylene gas is used for. Please remember these 3 points are very important. One is the important is the welding purpose, cutting purpose, hard metal cutting purpose. Second is artificial ripening. Third purpose, that is a so many for the dyes, rubber industry, plastic industry, and also in the perfumes. That is a preparation purpose. The purpose ethylene gas is used. Okay. The last topic in this chapter is, so here the important is what? First introduction part, 5 questions are the multiple choice question. Next is the preparation and properties, the 10 marks question. Separate is the 5 marks questions are how to prepare the acetaldehyde, how to prepare the oxalic acid from ethylene. These are the 5 marks bit. Next is how the acidity of alkynes. Acidity of alkynes. Explain it. This is a 5 marks question. I can explain very simply acidity of alkynes. Why? Because it is also given some complication in your book. You can't properly understand the acidity of alkynes. Now, please just listen here. Acidity of alkynes. Particularly, I am explaining with the alkynes. The alkynes in the first member is the what happened? Something full screen is not getting. Okay. So the first member of alkynes is ethylene. Okay. First member of alkenes is ethylene. First member of alkanes is ethane. Okay. This is the ethyl. This is the ethene. So ethyne, ethane, ethene, and ethane. I am using of the 3 names for the comparing. Here, ethane is more acidic than ethene. Ethane is acidic than ethane. That means less acidic is ethane. More acidic is ethine. Why this is the more acidic in nature? Because due to gradual increasing of S character in the ethine. Gradual increasing of S character. How it is, sir? Again, just listen here. I'm writing off all the 3 compounds names. First is ethine. This is commonly called as ethylene. Okay. Next is ethene, commonly called as ethylene. Next is ethane. Okay. The structural formula is, please see the structure. This is the ethylene. Double bond. This is ethylene. This is ethane. See? Okay. Now the 1 point, second point, I am explaining the acidity character. And third point is this triple bond undergoing of sp hybridization. This undergoing of sp2 hybridization. It is undergoing of sp3 hybridization. Okay. That means ethane is undergoing sp3 hybridization. Ethene is undergoing of sp2 hybridization. And ethylene, that means ethyne is undergoing of sp3 hybridization. This is the hybridization, third category, hybridization. Next, fourth point is S character. How much the S character is present in the ethyne? S character is how much in the ethylene or ethylene gas? Ethylene gas is S character is 50%. Okay. In the ethene, the S character is 33%. In the ethane, the S character is 25%. What I say is, why the acidity of alkyne means due to gradual increasing of S character. I told that gradual increase is 50%. This is, sorry, 25, 33, 50. It is increasing order. Okay, 25 to 33, 33 to 52, 50%. So gradual increasing of S character. That's why ethylene gas is acidic in nature. So if it is increasing or gradually increasing, that S character increases. Why? Because if the S character is increases, what happened? The bond between the carbon and carbon hydrogen very close each other. The carbon hydrogen bond is very close each other. Here the bond length of the carbon hydrogen is 1.07 angstroms. Here the bond length of this particular is 1.04 angstroms. Here the carbon, that is a 0.9 angstroms. The bond length between the carbon and hydrogen very close. If the close of the hydrogen to the carbon atom easily loses the proton, the main hydrogen is loses. Proton loses is called as acidic in nature. That's why this is the acidity of alkyne means ethane is more acidic than ethane. That you have to explain by means of these 4 steps. First is the formula, hybridization is, next is the S character. So S character from the ethane to ethylene, the S character is gradually increases. Due to the gradual increasing of S character is called as a high acidic in nature. So hence alkynes are more acidic than ethene and than ethane. That's enough for your answer. This is always important 5 marks bit. Okay, this is the last topic of this chapter. Now in the organic chemistry, second chapter is aromatic hydrocarbons. What are the aromatic hydrocarbons? Second chapter, aromatic hydrocarbons. So in this aromatic hydrocarbons, the best example of aromatic hydrocarbon is benzene. First is the benzene. Please listen here the benzene. What is the benzene? How the benzene is present in your structure? So in the aromatic compound, benzene is the first member of aromatic hydrocarbon. This aromatic hydrocarbons is also called as Arienes. Our next chapter is Arienes only. This aromatic hydrocarbon is also called as Arienes. So in that example, the benzene is there. So what is the benzene? What is the aroma? Aroma is a Greek word. Greek word is aroma. Aroma means what? Pleasant smell. You are getting a smell of aroma. When biryani is cooking, you are getting a full aroma. Why? Because you are using of the so many ingredients. That aroma is getting off. Oh, somewhere the biryani is there. Suppose you are using a perfume, that aroma is there. Okay, so like that you are having of that aroma smell is there. That pleasant smell will be there of the particular whatever the compounds you are having. Benzene, you can't know the smell, but you know the naphthalene. Naphthalene, where you are using your household purpose, you are using the naphthalene, naphthalene balls for your that is particularly washrooms. Naphthalene balls, or you can using of your clothes also. Insects will be not coming to the clothes. The naphthalene, phenanthracene, anthracene, benzene, these are all are aromatic hydrocarbons. So first member is a benzene, next is the naphthalene, next is the anthracene, next is phenanthracene. These are aromatic hydrocarbons which is having of aroma smell is there. Now coming to the benzene. The first name of the benzene was, it is first year, the name of the benzene was discovered by the Faraday in 1825. Faraday is discovered in 1825, the benzene. Please, this is the important of your structure of the benzene. They will ask in the examination. You can explain that first Faraday is discovered the benzene in 1825 from the whale oil, destructive distillation of the whale oil. Whales are present in the oceans. So that whale is cutting, that is our liver of the whale is destructive, that oil is extracted. That oil is consisting of the benzene. That is first discovered by the whale oil by the Faraday. And the next, the name and the molecular formula. Name of the benzene, name is benzene. The name as well as the molecular formula. What is the molecular formula of benzene? Molecular formula is C6H6. This is discovered, or you can say this is a particularly determined. The name benzene as well as the molecular formula is determined by the Mitscherlich. Mitscherlich is a scientist which is discovered or name of the compound that is in that particularly after the discovery of that particular Faraday in 1834. The formula and the name was proposed by the Mitscherlich in 1834. Faraday discovered the benzene. but is not named the name of the benzene. He discovered that means whale oil. Whale oil is consisting of aroma smell is there. He says that's all. But the name is proposed by the naturalist and also derived the molecular formula. The molecular formula is C6H6 is the molecular formula. Next, often is also discovered this particular benzene C6H6 from coal tar. In the coal tar, you are having up means you are getting up the crude oil. Last stage is called as a coal tar. Before that, you have to destructive distillation. You are getting up the benzene. That is a C6H6 is there. So coming of all the things we are seeing of this one, particularly Faraday's and Mitscherly's and also Hoffman's, they are believed that the benzene is a C6H6 and also is a molecular weight is 80 grams are there. The molecular weight is there and the formula is C6H6. It is consisting of very, very unsaturated hydrocarbon, just like C2H2. Means it is nothing but CnH2n minus 2. So the same general formula, they derived as the general formula is CnH2n minus 6. Just like the CnH2n minus 2, what you are getting in the previous chapter, there is alkyne chapter. CnH2n minus is alkynes, and the benzene is CnH2n minus 6. That means it seems to a very, very unsaturated hydrocarbon. By the seeing of the molecular formula and molecular weight, you are observed that the compound is unsaturated hydrocarbon. Unsaturated hydrocarbon always undergoing addition reaction. Just now you have prepared the properties of the alkynes. Undergoing of hydrogen, undergoing of halogenation, undergoing of hydrogen halide, undergoing of water. All properties are just now you saw. Okay. So similar manner, the benzene the formula seems to be, it is a unsaturated, very, very unsaturated hydrocarbon. It must undergo addition reaction. But fortunately, the benzene does not undergoing addition reaction. Benzene does not undergoing addition reaction. It is undergoing substitution reaction. It is very difficult. Why? Because only saturated hydrocarbons can undergoing substitution reaction. Unsaturated hydrocarbon undergoing of addition reaction. Here the benzene formula seems to unsaturated, but undergoing saturated, that is substitution reaction. This property, this character is called as aromatic character. What is aromatic character? In the examination, they ask the 5 marks question. The formula seems to unsaturated, but it does not undergoing addition reaction. It can undergoing substitution reaction. This phenomenon is called as aromatic nature, aromatic hydrocarbon or aromatic character. You can explain. So which are the examples of aromatic compound? Means benzene is aromatic compound, naphthalene is an aromatic compound, anthracene is an aromatic compound. Okay, these are the 3 important examples. We are write the aromatic nature. Aroma means a pleasant smell, a very fragrant smell you are getting off when you are using of perfume. How you are getting off that one? Okay, when you are using of other whatever the vanilla essence, how the smell is there, that is aroma will be there. That aroma will be coming of this particular aromatic hydrocarbons. So this is about the introduction of that one. Next we are having of a structure of benzene. What is the structure of the benzene actually? You are seeing the formula only C6H6, but seeing of this one CnH2n minus 6 is the general formula you are getting. So what is the actual structure? So many scientists are this particular structure purpose, they are spend a lot of time. From 1825 to the first 1820 Faraday is discovered. 1834 Mitscherlich is derived the name and its molecular formula. Then after they are discussing about the how the structure is there. Why? Because it is a nothing but it is a very unsaturated hydrocarbon. If the unsaturated hydrocarbon means the molecular weight and molecular data, it is getting of the that is a unsaturated compound. If the formula is hexane is there, so hexane means C6H14. H14 is there. This is hexane. This is saturated hydrocarbon. But this is C6H6. How many number of 8 hydrogens are less than this one? This is consisting of so many are there. So there so many scientists are observed the structure of hydrocarbon. That means a benzene structure. So in the examination, it is a 10 marks bit for the structure of benzene. What is the structure of benzene? Here so many scientists are there developed the structures of the benzene. In that, the important why, because then when the benzene undergoing of addition reaction with the 3 molecules of hydrogen, 3 molecules of chlorine, 3 molecules of your ozone, that is also present, chlorine, hydrogenation, and also halogenation, and that is a ozonation. These all are three molecules undergoing addition reaction. See this particularly I'm using of why, because I don't want to explain before structure, but when if you are feeling as this is the benzene ring, this is undergoing of 3 molecules of hydrogenation, this addition of 3 molecules of hydrogen in presence of the catalyst, nickel catalyst, you're getting of cyclohexane. This is a benzene. When 3 molecule means it is a cyclohexane. Similar manner, if you are using of this benzene, if you are using a 3 molecules of chlorine, 3 molecules of the chlorine, you are getting of this is a see C6H6Cl6. This is benzene hexachloride. Benzene hexachloride is from, that is nothing but the gammaxine powder, that is a BHC. Benzene hexachloride, BHC, it is called as. Okay, and 3 molecules, 3 months. That means it seems some 3 is a very important one. There is a or double bond is there, triple bond is there. There is no idea regarding of this one. For that purpose, for this seeing of the molecular formula or molecular weight, so many scientists they are prepared. That means they draw the structures of that one. How the benzene structure is there. Some of the scientists are believed that there may be having of this is a structure, that is a having of the structure is there seems to be a little bit of difficulty is there. I'm trying to in your book, your manual, you are having of the structure of the benzene, page number 76. There so many that things are there. This is a one type of structure is given by the one scientist. There is a triple bond. See, this is the structure is given. That means a triple bond is there, remaining single bond letter. It is not true, but they given the structures. Some of the scientists is given as like this: CH2 double bond, C, CH single bond, and there is a triple bond, and C, CH, then it is a double bond is given. Like there so many are there, but there is no proof. Why? Because triple bond, how can it exist? Here double bond, triple bond, or double bond. How can it exist? There is no explanation. So like that, you are getting of the triple bond is there and double bond is there. In that, mainly important of the Armstrong base structures are important. How they are concluded as, why? Because if you see that one benzene, when C6H6 is hydrogenated, that means you are getting of 3 hydrogen, formation of cyclohexane. Or you can see C6H6 in presence of 3 chlorines, you are getting of BSC, benzene hexachloride is formed. It seems what a cyclic structure is there. So Bayer and also Armstrong believed that benzene is having of cyclic structure, not open chain structure. Previously, what you see that benzene structure, CH2 double bond, CH single bond, CH triple bond, CH like that I am written. It is a straight chain structure. But when seeing the addition reaction, when the hydrogenation or halogenation, we are getting of hexagonal cyclic ring is there. So benzene may be having of the cyclic ring. They told like that, they draw as a Bayer and Neil Armstrong. That is Armstrong and Bayer structure is they have as like this a hexagonal ring structure. This hexagonal ring structure is having of this is a bond is present. See, this is a carbon, this is a carbon, this is a carbon, carbon, carbon. Here on this carbon, there is a double bond is there. There is a double bond between this carbon and carbon. And also the hydrogens are like that. It is replaced by the whom? Bayer and Armstrong is explained the structure. Bayer and Armstrong is says the structure. And one more, Dewar structure also very important to contribution of this benzene. Dewar structures. Please, friends, here you have to write all the structures. The straight chain structures, Armstrong Bayer structure, Dewar structure also. Dewar is explained as like this exact, that a pentagonal ring structure is there. The pentagonal ring structure is consisting of a cyclic nature is there. This is, see, it is a different, that means here carbon, 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 carbon is there. Here hydrogen is there. There is a hydrogen. There is a hydrogen. There is hydrogen. This is explained by the Dewar. And one more Dewar structure is also present like this hexagonal ring structure. Okay, this hexagonal ring structure consisting of all the bonds. See, every bond is linked with the one another carbon. There is a hydrogen, there is a hydrogen, there is a hydrogen, like this E explained, Dewar is explained. Like that, so many tails, tail structure. If you see this one, tail is also explained the tail structure. See, scientists are so many art is explained this particularly. Why? Because up to from 1825 to 1865 there is uncertainty is there. 1825 to 1865 there is uncertainty of the structure. 1825 Faraday is invented this particular benzene. The name benzene and the formula is invented by the Mitscherlich in 1834. And the remaining in the after from the 1834 to 1865, so many scientists, Hans Bayers and also Dewar and Thales and so many others also, these structures are developed. In that Thales structure is, it's very simple. It is reality to the benzene one. There is alternative bonds are there, but he explained as these are the electrons will be localized on the single bond. I hope you can clear this one. On the single bond, let us see. I'm clarifying this one particularly. Why? Because this tail structure is very important to us. This is explained as exactly hexagonal ring structure. This hexagonal ring structure is having of alternative single and double bond. On the single bond, the pi electrons are delocalized. The pi electrons are delocalized. It is given by the tails. Okay, they all are present. So in the 1888 to 1897, one of the scientists, that is a particular Kekulé, is researching on this particular benzene only. That is called as Kekulé's benzene structure. Is a final structure. Today we are using of this particular after the so many scientists are proposed these structures, but there is no proof at all. But the Kekulé is doing the research on particular structure of the benzene. In the 1865, he got the only dream of the when the snake is dancing. During of the dancing of the snake, the tail and mouth comes very close to each other. So it seems that the hexagonal structure. Immediately he wake up and draw the structure of, that is a benzene structure, that is called as a Kekulé structure. That is the final structure. Today you are using of the benzene. What is the Kekulé structure? Is Kekulé structure. He has explained as benzene is a hexagonal ring structure. This hexagonal ring structure is consisting of, there is an alternative single and double bond are there. This is the alternative. This also seems to the same similar manner of, once this double bond is replaced here, so there is a both are similar structure. They explained as this is the resonance hybrid. You are using of a circular form. There's electrons, 6 pi electrons are delocalized pi electrons are there. The 6 pi electrons will be delocalized one. Then you are using of this one is a benzene hexagonal ring structure. That means here the carbon is there, here the carbon, and hydrogens are present like this. This is 1865. The calculate is determine the structure. Now you are using this one only, the calculate structure. There is a resonance hybrid is there. That exactly all bonds are equal in length. Don't write that one. Exactly all bonds are equal in length is there. So you are getting of the calculus structure and the resonance hybrid is there. So due to of this one, Devers, and also you are having of the tails and also Bayers and also your Armstrong and remaining others, they have to write, explain. The finally conclusion of the benzene structure is Kekulé is invented in 1865 with the dream only. The research is only the, see the how we are getting off 7 to 8 years in the laboratory worked, but won't get the structure, proper structure. But that in the during of the dream, why? Because he's thinking about the structure only for all day. That means 24 hours they are thinking. So only dream is came. That is the truth of the structure of this one. That's why it is called as a Kekulé structure. So you have to using of the Kekulé structure. The benzene structure is formed. That is used as a benzene one. So in the examination, they will ask the what is the benzene structure. You have to draw the Kekulé structures, Devers structures, and also and the tails. That is the remaining others also. So next is you are having of the aromaticity. Already I told that what is the aromaticity. When the formula seems to the unsaturated, but it does not undergoing addition reaction, it can undergoing of substitution reaction. If this particular explanation, this particular character will be there by any compound, the compound behaves as a aromaticity. That is called as aromatic hydrocarbons. Aromatic hydrocarbons are, the examples are benzene, naphthalene, anthracene. You can use as this the aromatic hydrocarbon. Next is the Uckel's rule. What is Uckel's rule? Uckel's rule, that is a 4n plus 2 pi electron system is called as a Uckel's rule. If any compound obeys this Uckel's rule, that is called as a aromatic hydrocarbon. What is the Uckel's rule? See that it is also example, that is your examination purpose. Uckel's rule. Uckel's rule is nothing but 4n plus 2 pi electron system. Pi electron system is called as Uckel. What is n is? N is equal to 1, 2, 3. It is integer. See example of this particularly. We are explaining of the example. When benzene is there, benzene molecular formula is C6H6. So if you do this structure is the benzene is the hexagonal ring structure, is having of alternative single bond, double bond, and means it is consisting of 6 pi electrons are there. If the 6 pi electrons, if you compare that 4n plus 2 pi electrons is equal to 6 pi electrons, means here we are having of the 4n. We are using of the n is, we are finding of the n, whether it is integer means it is aromatic carbon. 4n pi electrons, that means you are having of the 4n 6 pi electrons. So removing of 4n is equal 6 pi minus 2 pi. 4n is equal 6 pi electrons. Okay, that means it is a pi means a electron. Pi electron means pi bond, double bond length. So 4 pi electrons are there. N is equal to what? 1. It is an integer. So it is an aromatic hydrocarbon. It is aromatic. Benzene is aromatic. By means of the Uckel's rule, you can explain whether the compound is aromatic or not. If you see the naphthalene structure is 2 hexagonal ring structures. This is an alternative single bond. See how many delocalized pi electrons are there? 5. 5 into 2 means 10 pi electron system. Naphthalene is a 10 pi electron system. Now you take this particular 10 pi electron system. In this case, just sure I'm using of this naphthalene. So this is about the benzene. 4n plus 2 pi is equal 10 pi. So 4n is equal 10 minus 2 pi. Means 4n is equal 8 pi electrons. N is equal to, n is equal to means it is integer. It is also aromatic compound. So like that he explained by the Oculus rule. So Oculus rule is also very important. And in this benzene, the resonance energy, how the resonance energy? Why? Because 3 bonds broken out. Each bond is consisting of the 28.2 calories of energy required to break the bond. Next topic is small 2 minutes. I will finish up after the Oculus rule. Resonance energy of the benzene. So Oculus rule in our multiple choice question, you can remember 4n plus 2 pi electrons is called as Oculus rule. Next is the resonance energy. Resonance energy. What is the benzene resonance energy of loss? See, the benzene is having of the this structure. Benzene is having of the 3 double bonds are present. Each bond, one means one hydrogen is where addition. It will takes formation of double bond is there. One is broken out, means you are getting of this particular hydrogen is added to that one. You are getting this particularly one hydrogen. It requiring of 28.2 kilocalories of energy is required. One bond to break in the benzene structure. One bond to break in the benzene structure, you requiring of 28.2 kilocalories. So means 28.2 into 3 means how much? 3 2s are 6, 3 8s are 24, 3 2s are 84.6 calories, kilocalories of energy is required to break all the 3 bonds. But in the case of the benzene, experimentally found that the resonance energy of the particular benzene is 49.8 kilocalories only. Experimentally you got the resonance energy is required of that one is 49.8 calories only, kilocalories. So by means of that one you are getting of, sorry, this is a 28.6. So 6 3s are 8, 24, this is 85.8. Okay, now subtracting this experiment value, it is theoretical value 0. So from 15 to 9 means 36 kilocalories. So benzene required, benzene is resonance energy is 36 kilocalories. This is a very important your multiple choice question. How much the resonance energy of the benzene? Means 36. How we are getting? By means of theoretical value, one bond to broken out or to break the one bond with the help of the hydrogen requiring of 28.6 calories of energy is required. For 3 bond means to 85.8. But actually experimentally found that 49.8 kilocalories. So the difference is called as resonance energy. Which resonance energy? Benzene resonance energy is 36. This is a maximum resonance energy is getting in any compound. You don't have that 36. Only benzene is having of this much of highest resonance energy is there. Due to why their resonance energy getting of resonance structure. Wow, what are the resonance structures? If you see the resonance structure, I will write the resonance structures from the bottom here. The resonance structures are, there is an alternative single bond is there. We are writing these are the arrow marks towards the both sides. These are the 2 resonance structures are there. Due to this one, this is a resonance hybrid. This is the resonance cell. Due to the 2 resonance structure, it is a stable compound and getting of the energy means 36 kilocalories, 36.0 or 36 kilocalories is required. This is about the resonance energy of the benzene. So by this chapter also finished. So in this case, what is the benzene? What is the structure of the benzene? And what is the structure after the structure of the benzene? We are writing of the what is the aromaticity, what is the Oculus rule, what is the resonance energy of the benzene. Okay, these are the important topics we are having of the in the benzene only. Okay, the preparation 1-2 preparation, that is a benzene diazonium chloride. You are preparing with the nitrous acid. You are getting of the benzene also. You can explain in the next Arienes in the group. You can preparation of the benzene also. You can explaining. Okay, so this is a important of the benzene. The next class onwards, you can go to the Arienes. That is the next chapter in this second block. Okay, so please. It is a mathematical expressions very easily to get the full marks from the chapter. 10 marks compulsory, 5 marks compulsory, every topic. alkynes you can take, or aromatic hydrocarbon, benzene you can take. Every one you will get the 15 to 20 marks in each chapter. So please focus on the organic part. You will get the full marks and also full very good marks also for your examination point of view. Okay, friends, today I am leaving. Tomorrow we will meet you. Okay, any doubts you can ask in the tomorrow first session.
Thank you so much, sir.